It's homework time! Yes! Happy! Homework time is here yet again. Let's start off in the right way. Start our name down at the top of the paper so you don't forget to do so later, because if you turn this bad boy in without a name, we know how that goes. Alright, and today's date. Sure, why not? Alright, today you write the actual date, where and when you are in this wonderful world of ours. Instructions for 1A say, plot the following points on the number line without measuring. Okay, so we're not busting out the ruler on this one. I'd like to start here with 3 3/4 because I find this one to be the easiest. So let's start with number 2 here. So we see our number line goes from 2 to 3 to 4, and our number that we're plotting is 3 3/4. Well, I think you're already seeing where I'm going with this, right? So here's halfway between 3 and 4, be 3 1/2. And then if we bisect those halves, we have quarters, right? 1/4, 2/4, 3/4, 4/4. And so 3 3/4 obviously is right here. We're at 3 3/4. That's it. That's all I have to say about that. All right, now looking at 1/6, 6 is an even number, so it's going to help us a little bit here, because we know that our halfway point between 2 and 3, well, okay, so our 2 1/2 point, how many 6 is that? All right, half of 6 is 3, so that's 3/6, right? And so if I take this section and put a 1/6 and a 2/6 in here, 1/6 and a 2/6, okay, that gives me a pretty good idea of where 2 and 1/6 in is. There we go. And now we need a slightly different strategy here with 33/9. You look at that and you're like, yeah, whatever. But let's go ahead and convert this to a mixed number like 1 and 2, be able to work with it a bit more easily. Couple ways we can do this. One way I want to show you, we've done the decomposition plenty, is to remember that fraction does express division. So you can essentially do 33 divided by 9, and your remainder will be the numerator of the fractional part of your mixed number. If that doesn't make sense, don't worry, just watch. Okay, 9, how many 9s in 33? 9, 18, 27, 36 would come next, that's too much. So 9, 18, 27. So 3, because 3 times 9 is 27, we subtract, and you don't have to do all the hop and scotch regrouping here, it's just 28, 29, 30, 31, 32, 33. Okay, so 6. So that remainder of 6, that's the numerator, and we're dividing by 9. So here's how that looks. Okay, so subtract, get 6. I should write that. All right, so there are 3 9s in 33 with a remainder of 6. And what are we talking about here? We're talking about 9ths. Okay, so you see how this works? Got it? The other way to do it is you could just decompose and say, hey, 33/9 is 9/9 and 9/9 and 9/9 and 6/9. And I put little plus signs in between all of these. And you see, so this is 1, 2, 3, and 6/9. Okay? So 2 different ways of looking at it there. Make life even a little bit easier. You probably look at 6 and 9 here. And because of all the work we did with simplifying and equivalent fractions and such, some bells are going off and you're saying, 6 and 9, they have something in common, which is that 3 is a factor of both. 3 is the greatest common factor. So we can divide 6/9 by 3/3 to simplify this and make it a little easier to work with. So that whole number 3 is going to remain the whole number 3. But 6/9, we can divide this by 3/3 in our heads. 6 divided by 3 is 2, and 9 divided by 3 is 3. So just expressing it as an equivalent fraction, 6/9 simplified to 2/3. And the reason I did that is because 3 2/3 is going to be a bit easier to place on this number line than dealing with 9ths. All right, so let's look at this. Now, we're looking at the space between 3 and 4, right? Because it's 3 and some. So I want to ignore my quarters and halves kind of for a moment, unless I'm going to use them as to help me section off. But basically, I want to take this whole area between 3 and 4 and split it into thirds. So I'll draw 2 lines to do that, right? Just as we did within a rectangle. So let's call this 3 and 1/3, and let's call this 3 and 2/3. And that is where we are labeling. And we're going to label it in its original form. I almost wrote, see that wavy 3 there for a reason. I almost wrote 3 and 2/3, but it's 33/9. That's what we started with. All right, now when we look at B, we're to use the number line where we just placed those, plotted those points, and compare the fractions using greater than, less than, or equal to. So 33/9, this part is easy. Compared to 2 and 1/6, well, obviously 33/9 is more than 3, 2 and 1/6 is less than 3, so 33/9 is greater than 2 and 1/6 is greater than. And now looking at 33/9 compared to 3 and 3/4. Well, again, you can just look at the number line and say, well, this is closer to 3, this is closer to 4, so 33/9 is less than 3 and 3/4. Wonderful, rolling on. And in number 2, we're doing the same thing, you see, right? Plotting some points on the number line. This one goes from 7 to 8 to 9, and then we'll do a comparison. Only difference here is we want to pay attention here to how we plot the points here in part A, because we'll be explaining that in part C. So let's go easy on ourselves. Let's look at 8 and 5/6 to start with, because the other ones you see are improper fractions. So as we just did, we just had one that was a 6, and we noted that 3/6 is the center point, equal to 8.5, right? 8 and 3/6, and that if we take the part here between the half and 9, and we draw 2 lines to split it into thirds, that will give us 6. All right, so this would be 3/6, 4/6, 5/6. So here we are, 8 and 5/6. See, we did the easiest one first. Great. Now looking at this one, we can easily see here that we can decompose this as, because we know our 8s, right? And we know 8 times 8 is 64. So we know that 64/8 is going to break out all of the whole pies that we can break out there, all right? And that would leave, of course, one more 1/8. And bring these back together now. What does that equal? Well, 64/8 is how many whole pies? It's 8, again, because 8 times 8 is 64. And if you find that confusing at all, this is something we did in a previous lesson, so honestly, I'm not going to belabor the point here. I could have broken this out as 8/8 and 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 said, okay, altogether that's 64/8, or it's 8 wholes, which is where I end up. The 64/8 is just a faster way of doing it using multiplication instead of repeated addition. So anyway, to place 8 and 1/8, I already have my half point marked here, right? So this is my half point. I know I can make quarters by bisecting the half. Yes, you got it. And then I can mark eighths by bisecting the quarters, right? So 8 and 1/8, 2/8, 3/8, 4/8, which is the half. So here indeed is 8 and 1/8, but again, I want to write it in its original form. It was given to me as 65/8, which is equal to 8 and 1/8. All right, now let's look at 29/4 and do the same thing. Skip count by 4s with me. 4, 8, 12, 16, 20, 24, 28. That's as close as I can get to 29 without going over. And there are 7 of them there. Take note of, remember that. So I can decompose the wholes, the whole pies, out of those 29 slices and say, okay, well, I have 28/4, right? And I draw a line there, draw a line there. And that leaves me with what? 1 more fourth, right? And so 28/4, remember how many pies was that? Yes, said keep note of that. It's 7. And then we have the 1/4, that one other slice. So 7 and 1/4. Now that's a lot easier to place here, right? Because we know halfway between 7 and 8 is 7.5. And then if I bisect the halves, it gives me fourths. So where's 7 and 1/4? Right there. But I'm going to write it again in a form that was given to me as 29/4 is right there. Beauteous. Now the comparing is easy, okay? So 8 and 5/6, we're comparing to 65/8. Well, here's 8 and 5/6 up towards 9. Here's 65/8 back towards 8. So obviously 8 and 5/6 is, right, greater than 65/8. And looking at 29/4, that's down by 7, comparing it to 65/8, which is greater than 8. So obviously 29/4 is, you got it, less than 65/8. So now, as warned, we have to explain how we plotted the points in problem 2. Okay, so what did we do? Well, where we needed to, or when I should say, when I needed to, what did we do with those improper fractions? We converted them to mixed numbers. Okay, so I converted, simply means changed, it's the math word, improper fractions to mixed numbers and then what did we do? How did we plot the points? Okay, and then plotted the points. Well, what we really did was we sectioned off, we partitioned, would be a good word for it. We partitioned the spaces between the whole numbers on the number line. Okay, and then plotted the points by partitioning. So we're using some math vocabulary here. The spaces between the whole numbers, and we did one more little thing in positioning these numbers correctly, is that we used the whole numbers and the half points as benchmarks of comparison. Okay, partitioning spaces between the whole numbers using them and the halfway points as benchmarks, and that's another vocabulary word we encounter a lot in Eureka here, as benchmarks of comparison. Now, I grant you that's a highfalutin explanation. It's more of a teacher than a student explanation, so don't go ahead and copy what I wrote necessarily. Write your own explanation. What did you do? How did you reason it out? And in the meantime, let's go on. And as they often do here in Eureka Land, they're going to have us do a whole bunch of practice here at the end just to make sure we can really put this to use. So this is valuable practice. So this is definitely no waste of time. This is good use. So we're to compare the fractions with greater than less than equal to and give that brief explanation. We've done similar exercises to this like back when we were doing equivalent fractions and other comparisons. And this is a big 4th grade standards, being able to compare fractions. We look at this first one, 5 and 1/3 compared to 5 and 3/4. Look, we know that 1/3 is less than 3/4, right? So we can set aside those 5 whole pies and just look at the fractional parts and say, well, they both have 5. Okay, so forget about that for a minute. We're really comparing 1/3 and 3/4. And we know that 3/4 is greater than 1/3. And that can actually be our our explanation here, we could say 1/3, and we can write this in math terms. We could say 1/3 is less than 3/4, and in order to fulfill the requirements here, 1/3 is also less than 1/2, right? So we can compare it to a benchmark fraction. So, and 1/3 is less than 1/2, where, or I should say whereas, but I won't be so fancy, 3/4 is greater than 1/2. So 5 1/3 is clearly less than 5 3/4. And see, I used the mathematical symbols and such there. So 5 1/3 is less than 5 3/4. All right, now when we look at this one, there are a couple of ways we can approach this. One good way, I think, is to find the equivalence here, because we look at 12/4, and you could probably see right away that 12 divided by 4 is 3, isn't it? It's 3 wholes. And now when we say 25 divided by 8, well, 3 times 8 is 24, which will leave one more eighth. So this is equal to 3 1/8. And again, that's something we covered in a previous lesson, so I am kind of skimming through that. So our benchmark fraction here is 3, right? So our explanation would be that 12/4 is equal to 3, and 25/8 is greater than 3. So that means that 12/4 is less than 25/8, right? Because 25/8 is greater than 3, whereas 12/4 is equal to 3. So 12/4 is less than 25/8. And by the way, I got to issue disclaimers now and then. If your teacher says, well, I don't really go for the way you explain this, okay, sorry. I would be quite impressed with this if a student wrote this. So, you know, hey, if your teacher wants you to do something different, then do that. And don't leave me nasty comments about it. All right, 18 divided by 6, we see that. We're getting good at this. We see, that's 3. So this again is equal to 3. Now look at this. 17 divided by 4. 4 times 4 is 16, which leaves one more fourth, doesn't it? And so the benchmark here is, I don't know, 4, we could say. So we could say 18/6 is less than 4, and 17/4 is greater than 4. So that means that 18/6 is less than 17/4. 18/6 is less than 17/4. And when you look at these, what do you notice here? Okay, well, they both have the whole number 5, so we can kind of set that aside for a moment because that's equal. What we're really comparing then are the fractional parts, 3/5 compared to 5/10. And I know you're looking at fifths and tenths saying, that's easy to find an equivalent. This would be 3/5 would be 5 and what would that be in tenths? We multiply by 2 halves, right? So that would be 6/10. All right. And to bring a benchmark into it, you notice that 5/10 is what? That's equal to 1/2, isn't it? So this is equal to 5 1/2. And this is greater than 5 1/2. So in our explanation, we could say that 5 3/5 is greater than 5 1/2, and 5 5/10 is equal to 5 1/2. So that would lead us to believe that 5 3/5, well, it's more than 5 1/2. The other one's equal to 5 1/2. Okay, so this is clearly more. 5 3/5 is more than 5 5/10. So it is greater than. All right, let's look at this one. In this case, it's actually better not to refer to the benchmark fraction. So I'm going to break the law because we know, look, we have 6 wholes in both of these, right? So we can set those aside. Really, we're comparing the fractional part. 3/4 compared to 3/5. We've seen ones like this. And we know that when you cut that cake into 4 slices, those are bigger pieces than when you cut it into 5 slices, right? The more you cut up that cake, the smaller the pieces get. And so we could say here, because fourths are greater than fifths, I should have written it that way, but you get the idea. So 3 larger pieces, 3/4, is greater than 3/5. And there, of course, it follows that 6 3/4 is more than 6 3/5. All right. If you really wanted to compare this to a benchmark, you could say, well, 6 3/4 is closer to 7 than 6 3/5. So if you want to add that in, feel free and fulfill the objective of referring to a benchmark fraction. Go for it. All right, so when we look at this one, 33/6 compared to 34/7. This is a bit of a tricky one here. There's a couple ways we can do this because we're dealing with 6 and 7ths, and we have almost the same number of each. What I'd like to do with this is convert these to mixed numbers so we can make a pretty straightforward comparison. All right, so 33 divided by 6 is, well, 5 with a remainder of 3, and we're talking about 6. And again, I did that kind of quickly because that comes from a previous lesson. Same thing here, 34/7. Well, 5 times 7 is 35, so all I can go to is 4 here. And that would be 28, right? 4 times 7 is 28, which leaves how many 7ths? 34 minus 28 is 6. Okay. 4 and 6/7. So now, see how that makes it a bit easier to compare to the benchmark, which would obviously be 5. So we could say that 33/6 is greater than 5, and 34/7, I know I messed up that 4 again, is less than 5. So that means that 33/6, well, it's more than 5, so this one's less than 5, so obviously it's greater, right? Greater than 34/7. So our answer there is greater than. And we just have a few more to finish up before homework time is through. Let's do it. All right, last few here. Let's do it. So we're starting off with 23/10 compared to 28. This is another case where I don't see any kind of shortcutty things we can do here. We just need to convert these to mixed numbers to make it easier to compare. Well, let's just divide 23 by 10. That would be 20/10, right? We could decompose it. We could do it that way as well. But so there are 2 10s in 23 with 3/10 remaining. So you see how 23/10 is equal to 2 3/10. 20 divided by 8, well, 8 times 2 is 16. 20 minus 16 is 4, and we're talking about eighths. And you notice right off that this is equal to what? Yeah, you're getting to where you can see those, right? This is equal to 2.5. Now, look here, 2 3/10. 2 5/10 would be a half, right? So this is less than 2.5. So 2.5 is our benchmark. So we could say that because 23/10 is less than 2.5, and 28 is actually equal to 2 1/2. So that means that 23/10, well, think about it, it's less than 2.5, and this one is 2.5, so that is less than 28. So our answer here is less than. Same thing here. Makes sense to convert these to mixed numbers and see better what we're doing. And division here is easy. Well, 12 times 2 is 24, which from 27 leaves how many 12ths? Leaves 3 12ths. And then over here, 15/6. 15 divided by 6 is 2. 15 minus 12 is 3, and we're talking about 6. And you see it, don't you, right? Just like in the last one, that's equal to 2 1/2, right? 3 is half of 6. So that's equal to 2 1/2. How many 12ths would be 1/2? That would be 6 12ths. So this is less than 2 1/2. So our explanation here is identical to the one previous, which is to say that, hey, 27/12 is less than 2.5, and 15/6 is actually, just like in the last one, is actually equal to 2.5. So what does that tell us about the numbers here? Well, it's saying that 27/12, that's less than 2.5. The other one is 2.5, so it's less than 15/6. And that's the answer we'll write here, less than. Now here, here we don't even have to do any conversion, because we can look and say, look, this is very close. This is 1/50th. So in fact, let's write that down. 2 49/50 is 1/50th away from 3, and 2 99/100 is 1/100th from 3. And let's add in the logic here to figure out which one is greater, which one is less. Okay, now think about it. Think about it in terms of money, right? If you're just a penny away from $3, as in 2 99/100, that's as close as you can get, right? So the 100th is smaller, so it's closer to 3. So that means that 2 99/100 is closer to 3. And that's the logic that tells us that 2 49/50 is less. Okay, not much, actually just a penny less than 2 99/100. So just to explain that a little bit more, if you took 49/50 and converted it to hundredths, you do so by multiplying by 2 halves, right? And you'd get 2, in fact, I'll write it down here. The equivalent would be 2 98/100, right? 49 times 2 is 98, 50 times 2 is 100. So you see, that's why I said it's just a penny less, but this one is closer. The other logic is to say that, well, hundredths are smaller, so it's less of a distance away. And we see something of a similar logic going on here, in that 6, they both have the whole number 6. Okay, so we can kind of set that aside, because really we're comparing the fractional part. 5/9. Okay, now this is kind of tricky. But what can we compare that to? If we try to compare it to 6.5, we have a little bit of a sticking point, but we can still do it. Because, well, what would 6.5 be in ninths? Well, it would kind of be 4.5 ninths, which, yes, isn't really a number, so to speak, but 4.5 ninths. But that tells us that this is more than 6.5. So 6 5/9 we can tell is greater than 6 1/2, right? And now let's look at 6 49/100. You see where I'm going, right? How many hundredths would be 1/2? 50 hundredths would be 1/2, right? So this is less than 6.5. So what does that tell us? That tells us that 6 5/9, think about it, is more than 6.5, and the other one's less. Okay, so this is clearly more than 6 49/100. So 6 5/9 is greater than 6 49/100. Hot dog and hallelujah. Look, you've done it again. You completed another homework time, so I will happily join you again. Next time, it is once again homework time.